This is the MakeHaven badging video for the Spot Welder. So welding is when you take two pieces of metal and make them one piece of metal. So there are a lot of different kinds of welding. Spot welding is a type of resistance welding. So it means that you take electricity and pass it through the two pieces, and the resistance of the metal means that it doesn't love the electricity passing through it, so it gets really hot, and then it melts, and then the two pieces fuse together, and then you have one piece of metal. And it does that here, just one little spot. So it has these huge copper conductors, and then they're focused just that one little point, and you're squeezing them together. And so when you're pushing them together, it helps just squish the whole mess up together in a good way and makes it one piece. So that's the deal. It's pretty safe as far as welding goes. So for a lot of kinds of welding, you need tons of safety gear, eye protection, body, from all the UV rays and the infrared and the, you name it, and the tons of heat that it produces. This is not very dangerous. You just need regular eye protection because it can shoot out some sparks. It's not a bad idea to wear long pants if you're doing a lot of this, or to put the apron over so your legs don't get hit by sparks. It is pretty low voltage. This one, I don't know if it says on it, probably does somewhere in the manual, but it's probably less than 10 volts. It does have a lot of amps. So it's just using a lot of current to melt the metal. That makes it not dangerous to people. It's not going to be able to get into your body with that low voltage. So you don't need to, you can just hold the metal when you're doing it. You don't need to worry about it zapping you or anything. So that's a good thing. And it doesn't produce tons of light, so that's great. It is pretty heavy, so don't drop it on your foot. That would hurt. In terms of the metals that you can weld with this, you can do steels, stainless, mild, galvanized, you name it. And in terms of the metals you can't do aluminum on this, or anything that's a copper alloy, so bronze, stuff like that. But most steels, no problem. And just to sort of reiterate, because I don't know if I really covered this, the purpose of this is to put pieces of sheet metal together. So it only does thin pieces, and let's say you're making a box or something, or a cover for something, or some kind of container. You would want to cut the sheet metal, maybe on the water jet, maybe some other way, bend it, fold it, and then you want to zap it together. So you use this tool, and hopefully you can just leave this on the table because it's heavy, and maneuver your piece to it, and then it pinches and tacks it together. So anytime you see a piece of something made out of sheet metal, it'll almost certainly be either tack welded or spot welded together. Those are synonymous. There are other kinds of spot welding, or at least people will call it. So, sometimes you could spot weld with a MIG machine, but what we're talking about is resistance in this case. So in terms of the thickness, for mild steel, you can do up to 1/8 of an inch combined thickness. And for galvanized, about 5/64, which is a little less than the 1/8 inch. That's two pieces of 20 gauge metal, for reference, if that makes sense to you. And for galvanized, it's probably better to do it under the hood in the welding area, so we'll go over there. It's probably not strictly necessary, but it's definitely a good idea. Anytime you have the galvanization on steel, the zinc, get really hot, it can produce fumes that you don't want to breathe in. And anytime you're doing this, if it is making fumes, just best to go over into the welding area so they get sucked up. You want to make sure that there isn't scale or oil or oxides or paint, grease on your workpiece, because that could start a fire, could just be nasty. So you don't want to have that. It will definitely make a not good weld. The things we're going to check are to make sure that the tips on here are in good condition. So sometimes they'll get really flattened after you use it for a while, and you can just grab a file and file them back to about the shape that they are. We actually have some spares here. So these are brand new ones, so you have a sense of what they look like when they're new. So that's just what you want them to look like. So you can use a file to make them look like that again if they stop looking like that. So we also want to make sure the tips line up really well, so they're not mismatched. If they do get misaligned, then you can just loosen the bolts that are holding them and realign them. In terms of the material, you want to make sure that it's clean, as we mentioned, and what I'm just going to do is take this M that was cut on the water jet and sort of fold it over so we have these two pieces that we can zap together, and then I'm going to use the vice grips, one to squeeze them together and two to hold it, just because it does a good job of holding. And you want the material to be in good contact, so I'm using the vice grips just to make sure that they're really close together, especially because I just folded it over. So, all right, so we have these two pieces. We're going to go over to the welding area to zap them together. So we're going to plug this guy in. So what controls the weld on here is how long you hold the button down for, the toggle. So you don't get to control how much amperage or volts or anything. You get to control how long you provide electricity for and how hard you squeeze. So we're going to set the tips so that they have nice good pressure on this. So that's good, and I'm just going to squeeze nice and hard. And actually I think we might want to tighten this down just even a little bit more. So I'm going to loosen that and then tighten this back one a little bit so I can get a little more oomph on this. There we go. If you don't squeeze hard enough, then it can make lots of sparks and it can actually stick to these, and then you have to like yank them apart. If you squeeze too hard, it'll just melt the metal and smush it all out of the way, and you'll just be left with a hole. So that's kind of a balance there. And then in terms of how long you hold it for, if you hold it for too long, it'll just vaporize the metal. And if you just tap it for a little bit for not long enough, it won't weld them together. So that's the balance you want to make sure. Alright, so we're just going to demonstrate. It's pretty straightforward. So I'm first going to hold down, get nice good pressure, and then we're going to sort of calibrate how long we need to hold it for just by testing. So I'm going to start just with a quick little zap. So you can see a few little sparks, and so it looks to me like that wasn't quite good enough because it just broke apart. So that really wasn't enough. So we'll try that again. Oh, so that I think was probably good. Yeah, so now those two are now one piece of metal. And so it just takes a little bit of practice to figure out exactly how long you need to hold it for. So if it's a thick piece or thicker piece of metal, you might need to hold it a little longer. Different kinds of metals, whatnot. And as you may have noticed, I actually forgot to put the fume hood on. So this just comes over, you know, as opposed to like some other kinds of welding where it's really critical. Here it's just sort of a good idea, but you just bring it over and flip the switch. And we'll just do a few more just so you can see. Here. So that is how you use the spot welder. It's pretty hot, so you want to wait a little bit for it to cool down. You can see that it's on both sides. It's totally zapped, and on one piece it leaves a little divot there. The tips still look pretty good, and that's how you use the spot welder. Thanks for watching.